Hello, Sydney. How are you all doing today? Good. My name is Kaif, and today I'm here to talk to you about common security pitfalls and how to fix them in OAuth. Before we do that, I wanted to start with a story. And this story is of King Midas, a very common story that some of you might know. But the legend goes something like this, that in the old Greek mythology, we had King Midas who wished for great wealth and success. So the god Dionysus accepted his wish and gave him a power that everything he touches will turn into gold. While that was super good to have at the beginning, pretty soon that blessing became a curse. Everything Midas used to touch turned into gold, whether it's food or water or anything. And the story kind of ended with Midas, his beloved daughter, turning into gold itself, which is quite of a tragic ending to the story. Um, and don't worry, I haven't walked into the wrong conference. The talk is more about OAuth, and we're going to explore how this powerful technology of OAuth can be a curse, if not, especially if not wielded with care. Now, a quick check on the room on how many of us are aware how OAuth works, a little bit on the internally. Show of hands. Cool, a few of you, which is good. It's totally fine if you're not familiar with OAuth. Although this is not going to be an intro to OAuth or how it works kind of talk, we will touch on all the relevant bits and pieces you need to know to understand the attacks. So let's continue with our story. It was a very, very long time ago in 2010. At least that's how it feels in my head. Um, the first OAuth 1 RFC gets published. So OAuth, which stands for Open Authorization, basically wanted to solve the problem, how can we share data between two apps without sharing the credentials? Now, unlike my mortgage app, which continuously asks for my bank password, back in the days, it used to be a very common thing. And you don't want to be giving away your sensitive credentials to every single thing. So that's where the question arises that, hey, how can we have a more connected ecosystem without having to give our credentials? And this thing picked on. So the very first implementations was actually around Facebook, where we saw third-party apps coming and saying that, hey, you can actually log into Facebook, log into our app using your Facebook credentials and seamlessly share your photos with one single credentials. And like any great technology, people asked the solid set of questions. Fast forward now, OAuth is unanimous. Every time you see a login screen, social login screen that says sign in with Google, Facebook, or Apple, or you connect to apps like you connecting your Jira with your GitHub so that you can share data across, that is some flavor of OAuth plus some other technologies at times, but it's mostly the OAuth that is powering that. So what is the Midas touch when it comes to OAuth? Now, fast forward from 2010 to now, OAuth has grown a lot. There's over 30 RFCs that detailing all kinds of use cases for OAuth. So whether you're covering, whether you're building a single page application or iOS or native app, or even a very complex SaaS product, there is some OAuth case that can cover you. That's one of the main benefits that comes with OAuth, that it gives the developers the option to implement all the bells and whistles they want to implement the way they want. And that great power of customization and flexibility soon becomes the pitfall where there is a very high chance of misconfiguration as well. Now, we're not going to cover all the misconfigurations that's going to happen in OAuth. If we try to do that, we'll be here until Monday, and I might need to be taken away in an ambulance. So we'll cover at least some of the very popular ones. So let's look at one. Let's take an OAuth functionality. Imagine we're building an app, and what we want to do is have our users the ability to log in via their social media accounts. Pretty plain and simple. So how do we do that in OAuth? There is something called the authorization code flow. So flows in OAuth are essentially procedures you can follow to securely exchange data. There's 4 of them. The authorization code flow is usually the most popular one and the more secure ones. No need to get too much details into the other three. We'll cover this one in depth in here. So how does the authorization code flow works? Let's understand it very, very briefly so we can understand the attacks as well. So here we have the three main parties. We have our user, which is using via browser. We have the photo share app, which is our app that we have made. And then finally, we have the social media side, which is the auth server and the resource server. But hey, what does that mean? So imagine you're trying to check into a hotel. Your client, or which is our app that is requesting the data, is like the hotel guest. The hotel guest goes to the reception desk and verifies all the permissions. So that's the job of the auth server. So it's verifying the permission and making sure that you are who you are. You show your passport. And then lastly, you have the resource server that hosts the data. So in this case, it might be your hotel room where we are trying to get access. Um, so the auth flow or authorization code flow starts something like this. The user tells the application that, hey, I like to log in via my social media. And our app goes, cool, hey, social media site, this user wants to log in via you. Can you make that happen? And this is the initiation of the OAuth flow. And it looks like this big scary URL that gets sent through. And all this orange bits is OAuth parameters that you need to configure. Again, don't need to worry about all of them, but the main ones is your client ID that tells you that, hi, this is the client app that's trying to connect. The redirect URI, which is after the user has signed in or validated, where do you go back? And lastly, the response type. So which tells us, hey, what flow to do. In this case, the authorization code flow is what we're after. So once you send in a request like this, the social media site will then ask the user that, hello, I am having someone ask that they want to connect. Are you sure? Do you want to authorize or log in? And this is the very age-old familiar screen you see where you, whenever you're trying to log in, that says that, hey, someone is trying to access your account. They are trying to access these information. Do you give them permissions or not? You guys have seen the screen a lot, right? I see quite a shake of hands. So that's your typical OAuth consent screen. Once the user says that, yep, it is I who want this, then the social media side that, okay, that's very good. Now some of the other OAuth magic starts to happen. We get sent an authorization code. So the authorization code is like a temporary token that gets exchanged for an access code. So it's like when you are checking into the hotel, you get a booking ID and you say your booking ID and you get, let's say, a room key card or something like that. So it's a one-time thing that gets used. So using that authorization code, you change for an access code. The access code is like any other API token that you can use to access more information. So yeah, imagine this request where you have you're sending a post request with the access code and a few other bits and blobs, like telling, hey, I'm the app that's trying to access and my secret, and you will get a response like this with the access code sent back to you. And what can you do using this access code? This access code is that hotel key card that we were talking about. Using this access code, you basically can access the username and email from the social media side and then lock that user in or do whatever you want to do. Now, in reality, there's a bit more complexity to it. These days, logging in happens using OIDC flow, where an ID token is used instead of an access token, but they're almost the same thing. So for our purposes, we'll just assume that's the case. And to be fair, there's still many apps that will still do the flow like this way, so it's totally valid. Cool. I know that was a lot. So let's very, very briefly summarize it. So we have the user request for social media login. Our app initiates the request and gets an auth code. We exchange that one-time auth code for a permanent access token. And using that access token, we access our data. That's pretty much the OAuth in a gist. Does that make sense? Thumbs up? A few thumbs up and nods, which is good. Phew. Then a food for thought. So how does our app even know who requested the auth code, authorization code in the first place? The short answer is currently it doesn't. OAuth without certain parameters is stateless. And anything that comes stateless and that complex has some interesting avenues of attack. So let's get started with that. So in this case, the players involved would be three parties. We would have the attacker, the victim, and obviously a vulnerable app. So how this attack works is the attacker initiates the OAuth request, like we saw, and it gets an authorization code back. We intercept this auth code. You can do it via like burp suit. In this example, like you can stop at that particular request and just drop that request, but basically get that code itself. Once you have the code, the request looks something like this, where it's that auth code back to you, and then the code itself and a bunch of other things. And the important thing to remember is the auth code is single use only. So using that auth code, we can now try to phish the user to click on that link. And it can be any phishing website that you can easily whip up. But at the back of that phishing website, there's two things happening, or there's two ways you can do the same thing. Basically, in the background, we are trying, whenever the user clicks or visits our phishing website, we're trying to restart that OAuth flow. So the rest of the OAuth flow is completed by the user. Remember, up until this point, the attacker started the OAuth flow. They logged into their Facebook or whatever. They got the auth token back, auth code back, and stopped it there. They haven't used the auth code to exchange for data yet. The prerequisite for this CSRF or type attacks is the user needs to be logged in session in their browser of the app. So in our photo session app, photo share app, let's say, the user already is logged in there. So when the user receives that access token and then continues the flow, they actually get back the attacker's username and email. What's the benefit in that? So the user's account, the account that is logged in into the browser, now gets associated with the attacker's social media. So the application request looks something like this from the user side. So the user browser sends that, hey, I've got this access token back. Can you please give me the email address and name associated with it? And the our application checks that access token, and it's like, yep, we have Mr. Attacker registered for who started this auth flow, and hence this auth token belongs to them. So we're going to send back Mr. Attacker's name and email. And in the browser, because our app doesn't know or have any state, it doesn't know who has generated the flow in the first place, it will take the attacker's username and email, and it would associate with our current logged in session in the browser. And that's the final flow. So whenever the attacker now logs in, it goes to photo share app and says, hey, I want to do social media login. It will actually log in the photo share app, but the user's account, not their account. And suddenly all the users' photos now becomes the attackers. So how do we solve this issue? Something called states. Not this one, we just need one, which is the state parameter. So the state parameter is a randomly generated unique parameter that is specific to a user's account. Again, what does that even mean? So at the start, a random value is generated and tied to the user's account. So whenever an auth request comes back, we check the state parameter with the with the user to see who is it the one who requested it or not. So to make things simple, or give an analogy, think of passport checks. When you go, you create a passport, and that is usually associated with some details of yours. And every time you go in and show your passport, we check the passport detail or the passport number, which is your state parameter, and then the details associated with that. So if I go and say that, hey, my passport number is this, it will say that, actually, sir, your name is not Mr. Bean, so you're not going to be able to use this passport. And then we move on. So we implement this check across our request. So this is our original request, which does not have the state parameter. We pop the state parameter into that request, which is a randomly generated value. And in our code, it looks something similar to this, where we are storing the state parameter along with the user ID and the timestamp. The timestamp is important because we don't want to be, let's say someone started an auth flow yesterday and that gets completed today. Now that is fishy. What took you so long to log into your Facebook? Things like that. So we wanted to make it time bounded as well. So we basically say that, yep, this is the auth code that the state parameter we generate, and here's the user associated with it. So, and we pop in that state parameter in all the requests that follow through from there. And once we receive a request, it looks something along the lines of this, where if it doesn't have a state parameter, we say, nope, it's false. This request is invalid. We check if the current user is the one who started the request, not start, sorry, apologies for the typo, started the request. And if it's not the person who started the request, we're like, no, sir, you can't, your state parameter doesn't match, it fails. Or if it is the user who started, we also check how long ago you started it. And if you took too long, we're say kindly, can you start it again? So that's pretty much it in terms of validating state, and our data now is safe. Which brings us to another type of attack. Let's try to change roles a bit. Instead of our apps asking for data, let's consider other apps asking us for users' data. Why would that be? So why would your app need to exchange data with others? In this day and age, some of the most common use cases you're seeing of you're opening up your app to others is obviously you have plugins and third-party apps. That's a more niche use case, but a better use case is probably having more better integrated user experience. So whenever I copy paste, let's say my Jira link or something in GitHub, I want to be able to see the issue's name or ID. Those kind of interchangeability happens via OAuth. Similarly, taking actions on behalf of the user as well. Whenever something happens in my app, let's say whenever the issue is updated, I want an automated Slack message sent to the relevant stakeholders. So those kind of interconnectivity is, again, these days, it's not just a wish list. Users expect your app to be integrated and available to other popular apps and ecosystem like that. So it's quite important you do that. And how do you actually ensure that you're not sharing passwords across with other random apps? Thankfully, this is a talk of OAuth, so we know that problem is already solved. And here, hence comes in the other benefit of sharing password, not sharing, having to share passwords with other applications. And what's the fundamental thing wrong with sharing passwords is it gives you access to the entire kingdom. So it's not just, if you imagine you wanted to check into a hotel and then your hotel key card, instead of your room, it gives you access to all the other rooms. That's a bad scenario. With passwords, it can be like that. But with OAuth, now we can lock it down. And the way OAuth manages to do that is something called scopes. Not this one, but something that looks like the scope check screen. Here, you're actually giving out explicit scopes to approve to your app. Now, scopes are really powerful. It makes it possible to have fine-grained control on the tasks you want the app to do and block the tasks you don't want the app to do. And that allows us, that makes OAuth so powerful because it gives you this very granular control, which otherwise wouldn't have been possible. And like Uncle Ben said to Peter, with great power comes great responsibility. So we need to make sure that scopes are being treated properly as well. Herein lies comes the second pitfall, where we have put in too much responsibility to someone that probably does not deserve it, and it can spiral in all sorts of ways. In particular, we're going to look at broken OAuth scopes. So what does that even mean? So the first even pitfall that can begin is overprivileged scopes. Imagine a request like this where an app starts to authenticate, but it in the meantime says that, hey, actually, this token you're going to give me, I need admin access, read, all write, all delete, manage users, and manage system billing as well. Why? Why do you need so much? A lot of the times, if you are oversharing scopes, that basically pretty much goes back into that root problem OAuth was trying to solve. Now, the audience here is fairly smart. You might be thinking, hey, why do we even give that broad scopes? What's the issue with it? So when we were rolling out OAuth and stubs in Atlassian, what we figured out that one of the biggest pitfalls is how do we even have smaller scopes? The applications we have often have very big permission models that do not accept very granular permissions like just read that particular issue or something like that. It assigns a user-based permission model. And that was an easy fix, but what that lead to is the second pitfall. Okay, sorry, I missed a slide, which was many apps, when they start, they don't have granular scopes. It's an easy fix. You just have granular scopes. But that leads into the next pitfall that we see a lot is something called scope explosion. So what's scopes explosion? So it's the case where our app has accumulated a huge number of weird scopes that it's too hard to manage. Let's have a look. So when we start, we have initial list of scope, which is all the users, and it's based around the users, which is great. But as our application grows in functionality and use case, the types of apps we want to integrate to, our scopes can hugely increase too. And what was super useful once can become really hard to manage, and you can even cut yourself with it. And a common example is when you're trying to create a request like this and you need to encode all kinds of scopes, it's really, really easy to misconfigure. And like we saw in the last demo, whatever is hard to misconfigure will be misconfigured. Sorry, what is hard to configure will be misconfigured. One of the good ways to get around this issue is implementing a scope hierarchy. So what is a scope hierarchy? It's basically a type of organizing your permissions in a tree-based model where you're saying that, hey, the admin is the top level and where you get all the permissions. But if you just want the profile view, you go down the tree step by step and until the section you have, and then only grant that. Having a tree-based model like this instead of just a flat scope, it reduces complexity a lot and it makes it easy to analyze as well. There's a bunch of other things. Scope is one of the big issues. Whenever the first step of OAuth is implementing scope, the next big challenge you'll see for organizations that maintain OAuth is how do you manage scopes? Now, we don't have time to go into all the different ways you can manage scope, but certain things I wanted to sort of bring in attention for you guys to investigate further on later is how can you do role-based scope grouping, things like scope templates. So instead of implementing scopes differently for every different functionality, having a template and achieving scalability through it. And lastly, regular monitoring of scope usage and audits based on that. We have found all kinds of funny things when we go back and try to do scope audits. Cool. Scope validation, though, or what to validate in a scope is only part of the problem. When to validate the scope is a very important other half of that whole puzzle that often can lead to the second pitfall, which is not validating scope on each request. And what do we mean by that? Imagine you are an application and you allow other apps to connect with you. What can happen is a malicious app or plugin can request elevated scopes from you than what the user approved. So imagine that Google screen where the user clicks on read username, read user email, and then sends it to the app, and the app requests that to you. But you can actually later on say that, hey, it's actually not just read, give me write permissions as well. So how does that work? Let's say the request flow, we say that read profile is what was requested. We send the auth code. When we are going to exchange that auth code for an access token, we can send the scopes again. And that's a functionality OAuth actually supports. We can say that, yep, actually, I want the access code, but sir, can you actually give me not just read profile, write profile, and admin as well? And if we don't verify at this point that this auth token was given for particular scopes, if there's no validation is there, we are actually going to send back that elevated access code, which will have read profile, write profile, and admin, which is very different from when we started the request for an auth code. Again, how do we solve this? One of the common issues is obviously we're talking about is tracking scopes in every major step, but scopes can be tied with your state parameter. Like we mentioned, that state parameter needs to be checked at every single time when you're sending in that request. Instead of just a state parameter with username and email, you can also chuck in the scopes that was requested by that parameter. And at any point, if that changes, you can track that, hey, the scope you requested versus what's in that state parameter does not match. So you can reject that. Cool. So takeaways for this. One of the biggest pitfalls of OAuth becomes a systematic way for managing scopes and ensuring that we enforce scope at every step of the flow becomes super important as well. Cool. Let's talk about another OAuth superpower. Now, OAuth, when the user uses it, they only see two screens. The first initiation that, hey, I want to connect, and the second screen, which is the consent that, yep, I want to connect this. But we know in the background that's not the case. We just saw under the hood how many stuff goes on. And just having to explain it on a high level made me literally look like this meme trying to draw some of the weirdest connections. But the good thing is the user doesn't actually see that. And which is this seamless flow is achieved by something called a redirect and callback URIs. So this redirect and callback URIs is a parameter that you configure that goes across along the flow, and it knows where to send the user back and take into different steps. So that ping pong that happens, that is powered by this redirect or callback URI. What is super important about this though is you configuring both the OAuth client and the providers configuring the redirect URI in the first place and configuring it well. Because if you don't configure it well, the user, after that initial check-in and validation, might come up into a scenario that they didn't really want or bargain for. So this in lies becomes another very, very common pitfall we see across OAuth is improper redirect URI configuration. We sometimes really don't know where did it come from and where are we going. Now, I was trying to see, okay, how can I do it a bit differently? So I was going to say if you redirect URI misconfigs where some people, how would they be like? So the first one we have that I trust everyone, which is you as a provider or a client not having any validation at all. And that's, you might think, yo, that sounds very risky, but you'd be surprised in so many apps, especially ones using OAuth 1, actually do not do a lot of this validation. So what's wrong with not doing URI validation at all? It can lead into this kind of sample attacks where the first one, the attacker just, instead of the original callback that is auto-generated, we pause that request using burp or anything, and then replace that redirect URI with our own malicious one, and then send it to the user for phishing. So whenever the user clicks on that link, they will see whatever OAuth that authorization flow, and they come back and they now into our malicious site. The other thing you can do is try to collect the tokens in URI fragments. So the auth token is sent across in the fragments itself. So if you craft an URI something along the lines which sends you to a site that will just collect the auth token along the way. And when the user clicks on it, their auth token will be captured and then sent to the attacker as well. The other more realistic case, to be honest, is what we see is around regex. Uh, when we're trying to validate URIs, it's not really one or two or three domains. We have often our applications have hundreds of domains and subdomains. And when we try to cater for it, it's very easy to make mistakes. Some of the examples with that kind of model is you can easily craft a regex bypass, which we saw pretty commonly out in the wild. And lastly, something called the double redirect attacks, where you start with the proper URI, but then you chuck in another parameter that, hey, a double redirect, but this time it goes back to this original site and then again goes back to this site. Sometimes the app processes it twice. Instead of this redirect URI, you could have used other prototypes like next, which in URL world means that when you go back to that, it will be redirected into that site. Lastly, we have the local host. It's very, very common to see that in the allowed redirect list because of testing or anything like that, any testing sites lingering around as well. And what that does is basically an attacker then do DNS rebinding or similar type of attacks to craft an URI that will pass your validation, but then takes them back to the malicious site. Next up, again, let's say you're fed up with regex. It's really a skill issue. You realize, you admit it, and then you move on with pattern matching that, hey, I'm not going to do that. I'm going to look for specific patterns. That in lies brings in another interesting point we have seen a lot in the wild is trying to match certain URL patterns that resemble their app, and that easily, again, can be done the same types of attacks of domain prefix or can be bypassed using a double redirect submit attacks. Cool. So takeaways from trying to protect URIs, exact matches is your friend. When possible, having the most exact match is what we want to be. Having an allow list when possible is also great. Again, like we mentioned, it's not just 1, 2, 3, or 5 domains. Sometimes it's hundreds. So managing this and having an allow list is difficult, but it's often well worth the effort. And lastly, if you're trying to use regex, please use with caution because that can often lead to more complications than you bargained for. Cool. Like in summary, we saw that we have a great power. So how do we wield it with great responsibility? If you're just developing an OAuth app, there's lots of good developer checklists. The one I try to use a lot is from this GitHub repo. It's quite comprehensive. It's quite old as well, 5 years ago, but it's still a lot of the checklists hold up. So it does the job. On the other hand, so with some really important things that we didn't really get to touch, it is flows around OIDC and a bunch of other ways OAuth can be exploited. If you want to dive deep into some of those, the RFC 6819, if you just search for that, that will get you to this RFC called OAuth 2.0, Threat Model and Security Considerations. It's one of those blessings that it's a gift that keeps on giving. Every time I have an OAuth related security review to do or just an app to develop, I go in and make sure that I'm checking all the boxes from this threat model. It's been really useful. With that, I conclude the talk. Thank you so much for listening. Any questions?
Hey, Kaif, thanks for the talk. I really enjoyed it. I had a question when you were showing off the redirect misconfigurations. One of the impacts was SSRF. I wanted to ask if that's usually like a full one or it's like blind.
It is usually blind because once the redirect happens, the auth code exchange and everything doesn't happen on the browser. That's happening more on the client's end from client app to the authorization server or the resource server. So sometimes in the redirect URI, we have seen things like path traversals where you can try to traverse path and try to get a response back that you're not supposed to get to, and other kinds of flaws as well. It's a bit harder to do, but definitely possible.
Hey Kaif, thanks for the talk. Just want to ask, with like the common likelihood of like redirect URI, I think it's, in my experience, I've seen it a lot, but in terms of validation of like the scope and whatnot, is that like something you see often in the wild?
For sure. Especially that's something that happens with more niche apps that don't have that granular scopes. They can, it's a two-way problem. So the first one is if you're the provider, you need to have that infrastructure to even support very granular scopes. And it's granular scopes and that principle of least privilege and everything is very easy to say that, hey, do principle of least privilege. But what we have found when you actually want to go and try to map all the types of requests that can come in and the resource you can achieve and map it to granular scope, it was very difficult, and it was a very long-term project that we need to run. The scope upgrade attacks is something that we do see a lot. So validation of that scope is super important. We see that all the time because especially if you are a relatively open application, let's say Google, right? Just using them, Google has thousands of, if not millions of apps in the marketplace. And a lot of those will require OAuth sort of integration with Gmail or Google. When you have that many apps and you need to trust a lot of them, you really need to ensure that you're not trusting them, because some of those apps or plugins or third party could easily be a malicious malware or something that tries to elevate scope later down the track. So yeah, that's something. Scope upgrade is definitely, we see a lot, especially if you own a marketplace or any kind of plugin based things. Like Atlassian has a huge marketplace. We always see those kind of malicious apps trying to do scope upgrade attacks. Any other questions?
Make me joke.
Hi, thanks for the talk. I was wondering about, is it common to see issues around mismatching the state parameter with the actual auth code itself? And so, you'd get, oh, this is the auth code, and you have a separate state code, and the state code is requesting different privileges that the original auth code was intended for, or something like that.
So if I understand correctly, so a state code was generated, and basically you take your state code and punch it to someone else and try to bypass. Is that what you're asking?
Yeah, yeah.
It's the similar type of protection, and I'm sorry if you're not familiar with it. I'm familiar with CSRF protection or CSRF tokens.
Not really.
Oh, okay. So to break it down into a very easily digestible way, so the state is tied with your user ID. So each state, when you look it up in your database, it is associated with the user ID. So when you, in a realistic way, when you look up the state and the user ID, that also has the auth code tied with it. Like, hey, here's the state, here's the auth code that was requested by this user. So that's where you do the validation. So that's where the cross check comes in handy. Does that answer your question? Happy to elaborate.
That's, yeah.
Like, put me there on the spot, mate. Cool. Any other questions? Going once, going twice. Sold. Yay. Thank you, everyone.
Thank you.
Talk.
And just a little present from B-Sides here.
Thank you so much. I know the talk's recorded, but if you guys want the slides, feel free to hit up. Happy to share that afterward. Thank you.